Welcome back to another AP Pre-Calculus video. Today we will be doing Worksheet A of topic 3.14, which is polar function graphs. So number one is going over, or it's asking us which of the following equation is this graph showing, or what equation is this graph showing. So let's go ahead and read the question. The figure shows the graph of a polar function r is equal to f of theta for this domain of theta in the polar coordinate system. Which of the following could be the expression of this equation, or f of theta? What we can do, since we have our function in the graph, so we know some points here, we can plug them in to theta. So plugging in the angle we see into each of the equations. So it's kind of like a x and y, or just a rectangular graph. Plugging in, like you plug in an x value to see if you get that y value. So it's like that, except a polar function, of course, which is, if you remember, it's radius comma angle, or r comma theta. There's going to be like certain things that might only eliminate two and then leave two answers, which after that we can use another value to check the last two. I think that's going to happen in one of the questions, but yeah, so let's get started. Plugging in for the angle here, I always like to start with 0, and we see 0 has a value of 2. We see it touches 2 there. So if we plug in, so this is the coordinates of 0. Plug in cosine or sine, we should get 2, so we have to do it for all of them. So let's start with A. 2 plus 4, and sine of 0, or 2 pi, is 0. So that gives me 2. Now let's move on. That looks correct so far, so I'm not going to cross that out. Let's move on to B. Sine, that's 0. That also gives me 2, so I'm not going to cross that out. For this one, this gives me 6, which if we look at 6, there's nothing touching 6 except for at pi over 2, but we did not plug in pi over 2, so no. So yeah, we only plugged in 0 here, which is 2 only. Yeah, it's only 0. If you look at this line, just to make sure you're not confusing with this line too, this line is not 0, this line is pi, which is completely different coordinates. It's -1, 0. So C is not correct. Now if we do D, 2 minus 4, 1, that would be 2 minus 4, which is -2. -2 is not correct because it's 2, so D is wrong too. And now that leaves us with A and B. Like I said before, we might end up with 2 answers after plugging in one value, so we should plug in another value. Another value that I automatically see is pi over 2, so just right here we can plug in that, and when we plug in that, it should give us 6. So we can plug that in with A and B. It should give us 6, but not 2. So plug that in. I'm going to use a different color to know that it's different. It's the other value I'm using. So it's 2 plus 4, and the coordinates for pi over 2 is 0, 1. So sine is 1, so that gives me 6. Looks good. For this one, it's 2 minus 4. That gives me -2, which is not correct. So I can cross off B, and our answer is A. Moving on to the next question here. 0 looks like it goes to 0 here. The first value I see from 0 is 0. So plugging in 0 from each of them should give me 0. So let's start with A. 3 plus 3. Oh, the coordinates for 0 again is 1, 0. So sine of 0 is 0. So it gives me 3, which is not correct. So I can cross off A. And B is 3 minus 3, 0. That also gives me 3. So it's not B either. And just so you know, 3 is like around here because it's in between 2 and 4. So just evenly divide the distance between 2 and 4. And doing C is 3 plus 3 cosine, so that's 1. So that gives me 6. Now I can cross that off. 3 minus 3, 1. And that gives me 0, which is, yeah, it's the point right there. That's 0. So it is D. So this question is asking the same thing here. trying to find out which equation fits this graph, this polar function. So we can start with 0. 0 has a 6 here, so plugging in each of them. For 0, the coordinates are 0, again are 1, 0. So for A, it's 6 cosine 2 times 0. 2 times 0 is 0. So cosine of 0 is 1, so that equals 6. So that's correct so far. So pay attention to the number inside that. We have to multiply 2 with what our angle is. The angle we're using is 0. We're not looking at the coordinates because that's the angle. Theta is the angle. And so 2 times 0 is 0. So cosine of 0, cosine of that angle is 1. So 6 times 1 is 1. And moving on to B, we have the same thing except it's multiplying by 4. So 0 times 4 is 0 again. So it's 1. So that also equals to 6. Now if we do sine, also sine times 2 times the angle, which is 0. So sine of 0 is 0. So that gives me 0. And so we can eliminate that, so because it should be 6. And now for D, 6 times 4 times 0, which is 0 too. So sine of 0 is 0. So 6 times 0 is also 0. So we can eliminate D. So it's either A or B. So now we can do another angle here. I can go pi over 4 here. If we look at pi over 4, we can see that it's going to be 0 for whatever we get with these. It should be 0. Let's plug that in here for this one. 6 times cosine of 2 times pi over 4. So let's do 2 times pi over 4. That gives me 2 pi over 4, which is equivalent to pi over 2. If we look back at pi over 2, which is right here, the coordinates are 0, 1. So the cosine of this is 0. So 0 times 6 gives me 0. If we look back at we need to look back at our angle. We might have used pi over 2, but that's not our angle that we plugged in. We have to look at the angle we plugged in, which is pi over 4. That did give us 0, so it looks like A is correct so far, but we need to check with B. So 6 times cosine 4 times pi. So I'm going to do 4 times pi over 4, which gives me 4 pi over 4. We can cancel out 4. That gives me pi. The coordinates of pi are -1, 0. The cosine of that is -1. So 6 times -1 gives me -6, which is not the angle, or is not. We don't see a whole polar function touching -6 at pi over 4. So we therefore can eliminate B, and our answer is A. Number 4, a portion of the graph of the polar function r is equal to f of theta. So we're not shown the entire graph. This right here is only a portion of the graph. So like a section of the graph only. The rest are cut off, where f of theta is equal to 3 sine of 2 times theta. So this right here is the equation of the full function, but we only see this much. And it is shown in the polar coordinate system for this is the restriction, or like where the graph is. This right here. Okay, so A and B are in between 0 and 2 pi. B is greater than A, and so we want to find out the values of A and B, which one of these correctly describes where this is. So if we look at it, we see that it's 3 pi over 2 to 2 pi. That would be D, right? But no, we can't just look at the answer choices. The best thing we do is to draw one of those rectangular graphs. It's like this thingy right here, where we draw our own graph, basically. I like to dash the middle line and then have straight lines on the top and bottom. And based on our equation, we can do the rest. So like 3, that's telling us our amplitude. The midline is always 0 unless we have a vertical dilation, which we do not in the equation. So 0, and the amplitude is 3, so 3 and -3. And we know our B value is 2, so to find the period is equal to 2 pi over B, and B is 2. This is 2, so we can cancel out the 2, so period is equal to pi. We know it's a sine function, so it should start in the middle and go up like that, like so. That should be touching the line, so I'm actually going to redraw the bottom line there. Okay, and so our graph should look like that. The reason why we want to draw a graph is because we want to know, this will help us figure out where each section of the graph is. So like, let's say this section is this section, we can know where this first section is based on looking on this rectangular graph. Using the period, we know a period of pi, or a period of sine, goes to here. It looks like that. So we know this right here is pi. Half of pi, this is half right here. So half should be around here. There's a value there, a value here and here. So this is 0. We know it starts at 0. Half of pi is pi over 2. Half of pi over 2 is pi over 4. And then here is 2 pi over 3. So that's our values. We can keep going here. So like pi plus pi over 4 gives me 5 pi over 4. And we can keep going if we need to, but for now I'm going to stop there. We can look at each of these intervals that we have in our answer choices and check it with this rectangular graph we just drew. So for example, 4 pi, or pi over 4 starts here. I'm going to use blue. It starts here and then goes down to pi over 2. And so if we look here, it's positive. I'm going to draw P positive there, which is above 0, and negative is below 0. So if we remember, positive means that there's no reflection, right? So if we look at the polar graph, we look for pi over 4. Pi over 4 is here. Pi over 4 to pi over 2. So that should be our section there. And because it's positive, there's no reflecting. It's above the 0, above the x-axis. So A, the answer choice A, should have part of the graph here, but there's nothing here, so we know it's not A. So I'm gonna erase that. I need to put back positive in there. All right, so I erased the stuff for A. Now we're moving on to B. We have starting at pi over 2, which is here, and then going all the way down, going all the way to pi. That entire section right here is below 0, so it's negative. That means when we look for pi over 2, which is here, and pi, so this entire section is going to reflect because it's negative. If it's positive, we should see the graph here, but it's not positive, it's negative, so we're going to reflect 180 an entire thing here, which is, we see the entire thing. So far it looks like it's B, so the section should be here, and yeah, what we see fills up this entire section, not this section. So it looks B looks good so far. So now moving on to C, we see 3 pi over 4, which is not on here, so it looks like we have to keep going, but 3 pi over 4 should be, if we multiply both by 3, because 4 times 3 gives us 12, so that's 9 pi over 12. So let's start here, 6, 7, 8, 9. So 3 pi over 4 is like here, which is in between pi over 2 and 2 pi over 3, so it's around here. And then pi, which is here. So there, that right there. So we have this section, but it's going to reflect. So it should be this section right here. But that's only half of the graph we see. It doesn't cover this half at all, so C is wrong. Remember, it has to do the entire thing, and nothing more, nothing less. And we see this goes the entire of quadrant 4. So D has 3 pi over 2 and 2 pi. So on the polar is right here. Yeah, that looks like it, but we gotta check on the rectangular graph. Is it negative or positive that we need to reflect or not? So it's not on here, so we need to keep adding values. So 5 pi over 4 plus pi over 4, that gives me 6 pi over 4, which simplifies to 3 pi over 2. So right here is 3 pi over 2. Then right here, let's do 5 pi over 4 plus, we can do plus 2 pi over 4, which is 2 of that. So that gives me 7 pi over 4. I don't want to use like this value because then I have to like change the denominator and everything. So yeah. And now then the last value is here. 7 pi over 4 plus pi over 4, that gives me 8 pi over 4. And 8 divided by 4 is just 2, so this is just 2 pi. So we can see that at 3 pi over 2, which is here, we're going to 2 pi, which is here. That's a negative. So that means that this answer choice D, the values of A and B, everything in there, it's gonna reflect over to this section right here. But there's nothing in that section. The stuff is at this section. So D is not correct. So make sure to not make that assumption that is D just because it's like that. We need to look at like the rectangle graph to see if it's gonna reflect or not. So our answer is B. So question number 5 gonna be the same thing like question number 4, so we're just gonna do the same thing. So when we read this, this is the equation right here. So let's sketch that out here. I'm gonna trace 0. So 0, there's no vertical. Translation. We have an amplitude of 3, so it's gonna be the same thing like the last graph. So 3 and negative 3. And a cosine graph, normally a positive. So a normal one is positive. It will start at the maximum and then go down from there and then repeat like that. And so that's our cosine graph. We have a b value of 3, so 2 pi over 3. That is our period. So we can see it makes one period here and then another one's there. So right there would be 2 pi over 3. And when we look at the polar, 2 pi over 3 is this line right here, times 4, that's 8, 6, 7, 8, so it's this line right here. So I'm gonna like trace that line so I know the values I might be putting, the rest of the values I'm gonna put on this rectangular graph, because like if I do that there, right, so you know I know half of that is gonna be here, which is pi over 3. So half of this, of the one period is pi over 3. Half of that I can see is pi over 6. So, which is right here, pi over 6. Also know this one's 0. And then here then, that one's just gonna be pi over. And so I have all the values in for one period. Then we can continue with the next period if we have to. So 2 pi over 3 plus pi over 6, so I have to multiply both by 2 to get this denominator as 6. That's 4 pi. So 4 pi plus 1 is 5 pi. So 5 pi over 6. And then this one right here is 5 pi over 6 plus pi over 6 is 6 pi over 6. Cancel out the 6's, so that's just pi. And then we keep going. We might need to keep going later, but for now I'm going to stop there. Now I have to check A, B, C, D. A is 0 to pi over 6. So if we look at this graph, 0 to pi over 6 is here, which is positive. So I'm going to erase all what I have on the polar graph. And so now I'm going to see where 0 to pi over 6 is on the polar graph. So 0 is here and then pi over 6 is there. Because it's positive, there's no reflection. So the graph should only be in this section, but it's not. It's this section. So A is not the answer. Now moving on to B, we have pi over 6, which is here, to pi over 3, which is here, so it's there. And it's negative, so it's going to reflect where we find it on the polar graph, which is here to here. It's not going to be there, we're going to reflect it, so I just reflected pi over 3, now I'm reflecting pi over 6. And so it should be here, but it's not. It's to the right of it, so B is also wrong. So cross off B. Now let's check C. We have pi over 3, which is here, to pi over 2. And then I'm going to trace that on here. Because it's negative, below 0, so that means we're going to reflect. And oh my gosh, it looks like what we have, the entire thing is in here, it's in there. So far it looks like it is C. So I'm not going to cross off C. But now we're going to go check D. So 5 pi over 4. We do not have that on there. 5 pi over 4, if I try to get a denominator of 12, that's times 3, that's 15. So 12, 13, 14, 15. 5 pi over 4 is here. So after pi, so pi plus pi over 6, so that is 7 pi over 6. This right here is 7 pi over 6. Okay, I might be intruding the space here a little bit, but hopefully you can see the stuff. this value, 7 pi over 6 plus pi over 6 is 8 pi over 6, which simplifies. 8 pi over 6 simplifies to 4 pi over 3. But 6, if we put it back to the original 6 pi, or 8 pi over 6 plus that's 9 pi over 6, which simplifies. 9 pi over 6, we can divide both by 2. That's 3 pi over 2. This value here is going to be 9, so 10 pi over 6. And we divide both by 2, that's 5 pi. That's 5 pi over 3. So we still haven't reached 5 pi over 4 yet. 5 pi over 4 is going to be in between some values. So we know 5 pi over 4 is here. 7 pi over 6 is this line right here. And so 4 pi over 3 is this line right here. So 5 pi over 4 is going to be in between these two. So it's going to be around here. And then b is 3 pi over 2, which is right here. We plotted that. So right here should be this line right here. I might be a little off, but yeah. So it's here, positive, so 5 pi over 4 to 3 pi over 2. So D has this section right here. I don't know if you can tell that the red stuff might be covering. So I'm going to erase it a little bit, but I'm going to undo it and put it back. So we can see here that what we have, oops, I'm going to erase it. What we have is within that, but it doesn't like touch this section at all. There's nothing, no part of this graph that's in here. So D is wrong. And so it's C. So now we have number 6 here. It's the same thing, so I'm going to draw that rectangular graph. It seems like we have a little more space though, so that's kind of nice. So we're going to read this though. A portion of the graph. Oh, they spelled graph wrong. Of the polar function, where this is the equation right here, is shown in the polar coordinate. Same thing, which the following could be the values for A and B. So yeah, okay, so it is the same kind of question. So this 2 right here, that means that we do actually have a vertical translation. So it's not gonna, the middle is not gonna be 0. Actually, it's gonna be 2. But we have an amplitude of 4, so that's 6. And 2 minus 4 is -2. So those are our values there. We have a cosine graph, so it's gonna start at the max and then look like that. That's kind of poorly drawn, to be honest, but it will do, right? So just in case we need that, I am drawing it. Okay, and now let's find out the period. Okay, so the period, B is 1, so the period is just 2 pi. So period ends here, so 2 pi is there, and 0 is here. So middle of 2 pi is pi. That's pi over 2. And this right here is 3 pi over 2. And just so you know, when it has a period of pi, it's just these lines right there that are the values, the 4 values. So now we can keep continuing this. So 2 pi plus pi over 2. That's going to be 5 pi, 5 pi, 5 pi over 2. But this is above 2 pi. So I'm just going to stop it there. So if we just look at the answer choices, actually, you should have probably done that first. We can see there are a lot, there are some negatives here. So we should extend the graph to the left so we can add some negatives here. So I'm actually going to erase some over here and then put my numbers to the right so I can draw the negatives stuff. Alright, so we have here, that should just be, so it should just be the same thing but negative, so. Alright, so I added that. So now we just look at everything. Here we have -2 pi over 3. 2 pi over 3 I remember as is 8 pi over 12, right? So it's this right here, so that's in between 2 pi, -2 pi and -2 pi and pi, so it's around here. So it's gonna be around like here, a little bit above, closer to -pi over 2 because it's right here. And then 2 pi over 3, the positive 2 pi over 3. So positive 2 pi over 3, it's gonna be in between the same numbers, closer to 2 pi, so around here. So here we have, I'm gonna trace it in the polar graph too, so, oh, you probably can't though. So -2 pi, that would be reflecting over the x-axis of pi over 2. So, or sorry, 2 pi over 3. So it's here and here. So that's the section we have. That's it, right? Okay, so from that, it looks like a little bit is negative, but the negative, and to distinguish negative and positive, it's with the 0, right? But we don't have the 0, so we have to kind of put in the 0 here. The 0 is in between 2 and negative 2, right? So 0 is kind of just there. That's 0, right? Yeah, but is the 0 really touching these values here? We don't know because we kind of estimated these 2 pi over 3. So to really check, we can plug in the value with the equation we have. So the cosine of 2 pi over 3, which is right here, that would be what would it be? It would be negative 1/2 comma that, right? It would be negative 1/2, that's the cosine. So 2 plus negative 2, and that gives me 0. So the 2 pi over 3's do actually touch 0. So it's like, it'd be around there, right? If we do negative 2 pi over 3, yeah, it would be the same x value. So it still gives us 0 too. So yeah, it does touch a 0. So the entire thing's positive. So there's no reflecting. So it's gonna be this entire area here. But our graph, it is in that area. It is in that area, but like this area right here and this area is not being touched at all. So A is not correct. So now moving on to B, we have negative pi over 3 and positive pi over 3. So pi over 3 is in between pi over 2 and 0. So the negative one's kind of there. It's closer to pi over 2. Because if we look on the graph, it's around there. And then pi over, it's going to be the same thing, but on the positive side, so around there. So B is this section right here. And so if we plot that into the polar graph here, we have pi over 3 and negative pi over 3. So, and it's positive. So it looks like the B could be the answer right now. No reflection. Positive means no reflection. Right? But we also have to pay attention to like the amplitude and stuff. Like the max that this section right here reaches is 6, but we can see our graph doesn't touch 6 at all. It's our graph, it doesn't look like this. If it looked like that, B might have been correct. But for now, I'm gonna keep it though, because it is in the correct section. But just to warn you guys though, that amplitude doesn't seem correct. So now C, we have pi over 2. Which is right here, to 3 pi over 2, which is right here. So that's a bit positive and negative. I'm going to put pi over 2 here. That's pi over 2, and then 3 pi over 2 is here. So the positive side is pi over 2 to, I remember this is 2 pi over 3. So 2 pi to 2 pi over 3. That is positive right here. So I'm going to shade in the spots that we have. We have that, but then we have to reflect from 2 pi over 3 to negative 2 pi over 3. This one right here. But negative 2 pi over 3 would also be, what would that be? 12, 13, 14, 15, 16. So it would be 4 pi over 3. This is 4 pi over 3 right here. So 4 pi over 3 looks like also, yeah, that's 4 pi over 3. 4 pi over 3 to 3 pi over 2, sorry. That's positive, so it would be here too. And then the rest, this section right here would reflect. So if I reflect that there and this one, so it should be there. This section right here looks correct. That's where the graph is, but we have these two sections here, which the graph is not on at all, so C is correct, or incorrect. Now D, we have 2 pi over 3, which if we remember, 2 pi over 3 was a little bit above, it was on the 0 that was above pi over 2, so right there. And then 4 pi over 3 is not on here. Oh, we did 4 pi over 3. 4 pi over 3 is right here. So D is right here. If we plot these 2 points, 2 pi over 4 is right here, or 2 pi over 3, and then 4 pi over 3 is right here. But because the entire thing is negative, we would not be over here, we would reflect these lines. So there and there. So that is our entire graph for D, and the entire our graph is there. And if we check, the amplitude is not the amplitude, but it goes to -2. It touches -2. The minimum is -2, and so that looks good. We see B was like right here, right? And D is here. So they did the same thing. They shaded the same areas, but B is touching 6 while D is touching -2. So therefore B is wrong because there is no 6 at all, but there is a 2. So it's D. Number 7, we have a new kind of question here. So the figure shows the graph of the polar function here, where equation here in the polar coordinate system for theta is greater than or equal to 0 but less than or equal to 2 pi. There are 4 points labeled A, B, C, and D, we see here, and E. E's in the middle. If the domain of f is restricted to this here, the portion of the given graph that remains consists of 2 pieces. So with this, when we restrict the domain to here, there will be only 2 pieces of this. So it's kind of the opposite of the last kinds of questions. We were given the parts of the graph. This one, we're given the entire graph, but we want to figure out where parts of the graphs will be. So one of those pieces is the portion of the graph in quadrant 4 from D to E. So I'm going to trace that. So D to E, so it's that part right there. So which of the following describes the other remaining piece? So with our domain restriction here, let's draw our rectangular graph. So we can find out what is happening during this restriction here. We can't really tell by looking at the polar graph because there could be reflections and stuff like that. So here's our equation. So amplitude of 6. And okay, so there's a 2 in there. That means B is 2, so 2 pi over 2. So the period is just pi. So it's normal cosine, so it starts at the max. Yeah, it's kind of poorly drawn, but whatever. You guys get it, right? So period ends here, so that's pi. Half of pi is pi over 2. Quarter of pi is pi over 4. And this one right here is 3 pi over 4. So that's 1 pi. We can continue that, but looking at the restriction, it's only from pi over 2 to pi. So we really don't need to continue adding more values. So it looks like that. So we can shade that. We need to find that into the polar coordinates and see what it will look like. So from pi over 2 to 3 pi over 4 is here, but it's here, but it's under 0, so it's gonna reflect. So it's gonna be here, which is the portion of the graph that's already given, but we're trying to find the other one. We have this part right here, and now let's find the other one. From 3 pi over 4 to pi is, again, this line to this line right here. But because it's positive, there's no reflecting, so it's just going to be there, so I'm going to shade it. So those are the two remaining, the 2 pieces of this graph with this domain restriction. So this looks like it's A to E, so our answer should be B. It says E to A, same thing. A to E. So it's B. Now our next question is, our next question is the same thing. We have a sine graph here instead, and this right here is our domain restriction. Which of the following describes the portion of the given graph that remains? Okay, so looks like there's only gonna be one thing remaining because it doesn't tell us another piece remaining. So let's draw our rectangular graph. Alright, it might be a bit uneven there. Okay, so 6 sine. So amplitude of 6 again, and it's a sine graph, so it starts in the middle. Alright, and looks like our period is pi again. I'm not going to do any extra work because we did pi last time. So in the middle of pi is pi over 2, so it's basically the same thing. and then this one is 3 pi over 4. So do we need to add in extra values? We do, because this right here, we don't have it currently on the rectangular. So oh wait, I'm sorry, we do have it. It's right here. So from pi over 2 to 3 pi over 4 is right here. It's a negative. So when we find it on the polar graph, pi over 2 to 3 pi over 4, I remember, is right here. We're gonna have to reflect it now. So here to reflect that. So our portion of the graph should be within the shaded region. And so that would be from E to C. A says E to A, no. A to E, no. C to E, or E to C. Okay, so these two, right? All right, but we know it starts from pi over 2. So pi over 2 is here. So it starts at E and then goes to C, which is 3 pi over 4. It ends at 3 pi over 4. So it should be D. It is D. It's D. So it's not A, B, and then it's either C or D, but it is not C because it's not going from 3 pi over 4 to pi over 2. So if we do look back over here, it's actually E to A and not A to E. E starts at, where does E starts at? E, it started at 3 pi over 4. A is not touching 3 pi over 4, right? So it's not A to E. And then A should be pi. Yeah, A is pi. It starts at 3 pi over 4 and then ends at pi. So yeah, the whatever comes first does matter. It depends on what's the first number. This is the first number and the last number. So yeah, that D is our answer. And that was topic 3.14. Hopefully that helped. And thank you so much for watching, and good luck on whatever you're about to take, a test, or maybe you're watching for the AP exam. Good luck.